Hello friends, we shall now start a new model, the performance of transmission lines. So this is a transmission line and this is the tower. Okay, as we know, the electrical energy or the power is generated at far off places from the utilization center. Okay, the electricity is being generated in generating station and then it is transmitted over a long distance to the load centers. I mean here load centers is where the electrical power is being utilized. So the transmission line transmits the electrical power from the generating station to the various distribution substations. So this transmission line having a uniform cross-sectional area throughout its length of the line. Okay, and here air acts as a insulating medium or a dielectric medium between the conductors. The electricity that is being generated and transmitted, it will be transmitted in the form of current wave and voltage wave. Okay, and for a safety reason, for a safety reason, the distance between the transmission line and the earth is kept more. Okay, so now the important things, important parameters in design and operation of the transmission line is voltage drop, percentage of voltage regulation, and line losses and transmission efficiency. These are the important parameters that is to be taken into consideration while designing a transmission line. These values are greatly influenced by the transmission line parameters. So we know what are the constants of the transmission line, which are, or we call them as a line parameters, that is resistance, inductance, and capacitance. For example, the voltage regulation or the voltage drop in the transmission line is influenced by the resistance, inductance, and capacitance of all the three parameters of the transmission line, whereas the line losses are greatly influenced by only the resistance, and in turn it will influence the transmission line efficiency. So here we shall develop a formulas to calculate the line voltage drop, to calculate the regulation, to calculate the efficiency. These formulas are very important from the two important reasons. They are important. First one is developing these equations will help us to understand what is the effect of these parameters on the transmission line. This is the first reason. Second reason is these formulas help us to develop an understanding what are the effects of these line parameters on the bus voltage and on the flow of power, electrical power. Okay, So these are some of the basic introduction about this transmission line. So the transmission line performance is calculated based on what is the voltage regulation of the transmission line and what is the efficiency of the transmission line. Okay. Further, the transmission lines are classified into three major categories. The first one is short transmission line. Second one is medium transmission line. And the third one is long transmission line. Okay, let us see that. For what we call it the short transmission line, if the length of the line is up to 60 kilometer and the power is transmitted at a voltage of comparatively low voltage, that is up to 20 kilovolts, then such line is called as short transmission line. If the transmission line length lies between 60 kilometer to 160 kilometer and the voltage at which the power is transmitted is around 20 kilovolts to more than 20 kilovolts and below 100 kilovolts, then such transmission line is called as a medium transmission line. And if the length of the line, transmission line, is more than 160 kilometer and the line voltage is more than 100 kilovolts, then such transmission line is known as long transmission line. Okay. Whatever may be the category of the transmission line, whether it is a short transmission line, whether it is a long transmission line, or it is a medium transmission line, whatever may be the category of the transmission line, the main objective is to transmit the power from one end to another end. Okay. And this transmission of the electrical power is greatly influenced by these two important parameters, that is percentage regulation and the efficiency of the transmission line. Percentage regulation is given by, it is a ratio of no load receiving end voltage minus full load receiving end voltage divided by full load receiving end voltage multiplied by 100. Okay. The sending end voltage, receiving end voltage, in the sense what, the transmitting end, the end where we send the voltage, we send the power, that is called as a sending end, and where the load is connected, that is called as a receiving end. Okay. Efficiency of the transmission line is given by, it is a ratio of power delivered at the receiving end to the power sent from the sending end. Okay. And the power sent minus line losses will give you power delivered at the receiving end. Okay. Every transmission line will have three basic electrical parameters. That's what we have seen. That is the resistance, inductance, then capacitance. The conductors of the line will have electrical resistance, inductance, and capacitance. As the transmission line is a set of conductors being run from one place to another place, supported by transmission towers, the parameters are assumed to be uniformly distributed all along the length of the transmission line. The electrical power is transmitted over a transmission line with the speed of light. It is transmitted with the speed of light, that is 3 into 10 raised to 8 meters per second. The frequency of the power is 50 hertz. Therefore, the wavelength is, see here, we have calculated wavelength is 6,000 meters.